Everybody. Today's lecture is going to be focusing on your sense of hearing. So let's go ahead and get started with some of the anatomical features of your ear. So ear is broken down to three parts. They are known as external or outer ear, middle ear, and internal or inner ear. External ear and middle ear function is associated with transmitting the vibration of the sound through the ear and eventually allowing those sound waves to reach your internal or your inner ear, where you convert those vibration of the sound to electrical impulses that your brain can process for the sense of hearing. And you also will have the ability to create your sense of balance or a spatial positioning of the head in terms of equilibrium as well. So basically figuring out where your head is located in terms of space. And it will make sense as we go through the PowerPoint today. Here is a depiction of your ear. You have, as I mentioned, your external ear, which is the auricle made up of helix and the lobule. You have the ear canal, which is also known as external auditory meatus or external acoustic meatus. The external ear is separated from your middle ear by this flattened funnel-shaped structure called the tympanic membrane, better known as the eardrum. Your middle ear is mostly made up of three bones. These are the smallest bone you have in your body, called ossicles, with the goal of transferring transferring the vibrations of the sound from the external ear into the internal ear. And then lastly, you have what we identified as your internal ear, made up of three structures. What you see on the top called the semicircular canals. These are three of them. You only see two of them in this picture. The midsection called the vestibule, and then what looks like the shell of your snail called the cochlea. As we mentioned earlier, the internal ear is essential in terms of both creating a sense of balance and equilibrium in your body, as well as your sense of hearing. You also can visualize in this picture what we have here called the pharyngotympanic or auditory tube that connects to your pharynx or your throat. That tube previously known as eustachian tube. So if you're studying the older textbook, you may see the word eustachian tube, which is again the same thing as the pharyngotympanic or auditory tube. Now, we already talked about external ear, but to just kind of review that, external ear is made up of your auricle or your pinna, which is basically the outer aspect of your ear, responsible for collecting the sound waves from your environment. It has two parts, the helix, which is the cartilaginous portion, specifically the elastic cartilage. And you have a structure called lobules, which is the fleshy part of your earlobe. The auditory canal, or your external auditory canal, or your external acoustic meatus, is the structure that basically runs and collects and transfers the sound vibrations toward the middle ear or toward your tympanic membrane. It does contain both oil gland as well as what we identified as ear wax. The ear wax produce the ear wax is what we identify as cerumen, which has a goal, believe it or not. It's not to just make your ear dirty. It contains material that can slow down the growth of microorganisms within your auditory canal, which is really important considering your ear canal actually opens up to the outside, which is where all of your basically microorganisms and harmful pathogens are present that can possibly cause harm to you. And again, the goal of these external acoustic meatus is to transfer the sound vibrations toward your tympanic membrane or your eardrum. Now, Tympanic membrane, which is that kind of flattened funnel-shaped structure we have, also called tympanum, connects or separates, I should say, your external ear from your middle ear. Think about your tympanic membrane as the surface of a drum. So when the vibrations of the sound reaches the tympanic membrane, it causes the vibration of the tympanic membrane, like the drum surface. And those vibrations can be passed down to the three middle ear bones, or your ossicles. And again, transfer that vibrations forward toward your inner ear. To kind of visualize the middle ear, remember that again, it is made up of three bones. Here is your tympanic membrane, and here is the three bones known as the ossicles. First one that is directly connected to your tympanic membrane is called malleus. It is shaped like a hammer. You have the middle one, which is called the incus, also shaped like an anvil. And then the third one within this series is what we identify as a stapes, and it's shaped literally like a stirrup. Now, the position where the stapes fits into the connection to the inner ear is called the oval window. And again, this is where there is a connection between middle ear and the inner ear or internal ear. Now, if I ask you guys, what is the goal of these three ossicles, these smallest bones in your body, the answer should be transferring of the sound toward the internal ear. But as we know, there are quite a few vibrations in our environment. Some of them are really soft, and some of them, especially if you're thinking about concerts, really loud music blasting to your ear through your earbuds, these can cause severe vibrations of these three tiny bones, and basically can cause either damage to the bones or to the tympanic membrane. And that can cause inability to effectively transfer vibrations of the sound, and consequently hearing loss. So one of the ways that your body can protect itself against possible damage to these bones is by having these really tiny muscles called tensor tympani muscle and stapes muscle. They are visualized in this picture right here. That's your tensor tympani muscle connected to your malleus. And then the smaller one of the two is the stapes connected to your stapes bone. Both of these basically come into action within 0.1 millisecond of, 0.1 second of your ear vibrating beyond the acceptable range, and kind of stabilizing these bones and the tympanic membrane to prevent damage as a result of severe vibrations. Do keep in mind that even though these muscles are there, if there is continuous loud noise that affects these bones, will eventually lead to hearing loss as a damage to either the ossicles or the tympanic membrane. Now, one of the interesting facts, as I mentioned earlier, is a connection point between what we identify as a nasopharynx and your middle ear. Now, if you are not familiar with what nasopharynx is, understand the word pharynx implies your throat. So that's another word for your throat. Your throat is broken down to three parts. Part that is behind your nose called nasopharynx. Part behind your oral cavity or your mouth is called oropharynx. And the part that is associated with your larynx or your vocal cord is referred to as the laryngopharynx. For today, we're only focusing on the first part of the pharynx, which is the nasopharynx. So there is a tube that extends from the nasopharynx, which is literally the back of your throat, to your ear. This tube is called pharyngeotympanic or auditory tube. As I mentioned, some people refer to it as the eustachian tube. Now, what is the goal of having this tube, which is basically what you have here in this picture? Sorry, one second. So this is what you have right here. That's your pharyngeotympanic tube. So why do we need this tube? So if you kind of think about this, there's two pressures involved in your ear. The pressure that is found inside your middle ear, and that pressure is separated by the tympanic membrane from your outside environment pressure, which is referred to as the atmospheric pressure. Now, under normal conditions, as you're sitting here listening to me, what you actually have is an equal pressure in either side of your tympanic membrane. That enables your tympanic membrane to easily move, and the vibration of the tympanic membrane allows the ossicles to move properly and give you the ability to hear very well. However, if there is a fluctuation in the pressure, in the atmospheric pressure, either the pressure going down as a result of elevation, sitting in a plane, or the pressure built up as you go, let's say, underwater. If this pressure changes, we have to have a mechanism to equalize the pressure in the middle ear with the atmospheric pressure. If you don't do that, either what happens is, if the pressure is higher on this side compared to this side, then it's pushing on the tympanic membrane, versus if the pressure is low here, like again, going on an elevation, the tympanic membrane is being pushed out. Regardless of which one I'm talking about, the tympanic membrane loses the ability to move freely with the movement of the vibrations of the sound. Therefore, your hearing will be affected. So if the tympanic membrane cannot easily move, then these ossicles cannot move easily either, and consequently your hearing will be affected. So what does your pharyngeotympanic tube does is that as you yawn or swallow, this eustachian tube or the auditory tube open up and basically open up your middle ear to the atmospheric pressure. As soon as this happens, then you have an equal pressure on either side of your tympanic membrane, and the pressure on the tympanic membrane releases, and the ossicles and the membrane can move easily to transfer the vibrations of the sound. So having this tube is really important in terms of equalizing pressure within your middle ear and the atmospheric pressure on the outside. Now, here's basically what I just told you in a written format. There is a secondary function associated with this pharyngeotympanic tube, and that is to allow the drain of the fluid that may build up in the middle ear. So if you, again, going back to the same picture, if you have fluid that is building up in this space right here and it has no place to go, right, that fluid is going to push on the tympanic membrane and limit the movement of the tympanic membrane. In severe cases, if you have significant buildup of fluid within the middle ear, you can actually rupture your tympanic membrane so you can have a way for the fluid to move out. Now, why are we talking about this? So let's talk about a couple of scenarios that is associated with this auditory tube. First thing is what we identify as airplane ears. Again, if you have ever traveled with a plane when your elevation is increasing, typically rapidly, you will notice this kind of painful distortion of the sound. So your ears are basically feel plugged. And the main reason is that the pressure on the external environment or your atmospheric pressure is dropping while your middle ear maintains its original pressure. That change on the membrane, tympanic membrane sides affect how your hearing will be decreased and the pressure causes the pain. Easy fix. Yawning, swallowing, or chewing gum while you're in a plane can help basically alleviate this problem. But again, if the plane is continuously changing elevation, you might experience this multiple times. As soon as you do these actions, these yawning, swallowing, or again, continuously chewing gum, this tube, this auditory tube opens up and causes the pressure to equalize. Now, we're also going to talk about what we identify as ear infection, also known as otitis media. So what is that exactly? So we know that there's fluid built up inside the middle ear, which normally gets drained by opening the pharyngeotympanic tube and basically releasing that built up of fluid into the nasopharynx. Now, there is, if you compare children to adults in terms of the number of ear infections you may see, children are going to be more susceptible to ear infection compared to an adult. The main reason for that is the positioning of the eustachian tube in an adult versus a child. So if I assume, and again, this is a really crude drawing. So if I assume this is my middle ear, here is my eustachian tube, and here is my nasopharynx, versus same picture, nasopharynx, and then middle ear. Here is an adult, here is the child. So in an adult, you have a more steep angle of the eustachian tube, which means that the fluid that is in the middle ear can drain easily with the use of gravity. In children, this tube is more horizontal, making the drainage more difficult. Consequently, if there is an infection in the nasopharynx, right, this infection can travel up and infect the fluid that is inside the middle ear, and that's basically what we identify for an ear infection. In an adult, because of effective drainage, and basically microorganisms have to travel up this tube to get to your middle ear, it's harder for them to accomplish the task, making adults less susceptible to ear infection. The good news is that if a child has continuous ear infections, there are solutions to that. So you can place this little tiny tube called an ear tube, and or also called tympanostomy tube, which you can see again in blue, placed it inside the tympanic membrane. So if you're looking at the picture, here is your tympanic membrane, which you can see kind of poking out here. That's your malleus that's connected to your tympanic membrane. So within the tympanic membrane, you put this tube. What is this tube doing is that it first allows for a really effective drainage of the middle ear. So you're not really relying as much to this eustachian tube for the drainage. If there is built up of fluid in the middle ear, it can easily drain through the ear tube, and therefore lowering the chance of infection. It also improves the hearing, again, because there is no built-up of fluid in the middle ear that can put pressure on the tympanic membrane. Now, interesting fact about this ear tube is that as the child grows and the body starts to heal itself, this ear tube slowly gets pushed out, and basically tympanic membrane returns to its original shape. Quickly, I didn't discuss that. Some of the symptoms of the ear infection would be logically pain, again, putting that extra pressure on the tympanic membrane. Limiting the movement of the tympanic membrane causes decrease in hearing. And anytime you have any sort of infection, one of the easiest way to identify that is having fever. So that's about it for our ear infection concept. So let's move on to the third part of our ear, which is known as the internal ear. So first of all, where is your internal ear is located in terms of your skull? It is located within your temporal bone. So hopefully everybody remember temporal bone and its location. And it is literally behind your eye socket. What is the job of your internal ear? So the main function, since this is your ear, the main function would be hearing. So you have receptors in your ear called hair cells, and these hair cells within a very specific space called membranous labyrinth are responsible for creation of your sound, or in another sense, converting vibration of the sound to electrical impulses. You also have another function associated with your internal ear called the sense of equilibrium or balance, what we identified as the vestibular sense from our nervous system lecture. So let's take a look at how these are created in our body. So I'm going to talk about the inner ear, and we'll continue talking about individual structures in part 2 of this PowerPoint. So quickly looking at the inner ear, you have the bony labyrinth, which is basically this structure. This is the protective shell, basically, if you want to think about it. Inside this bony labyrinth, which is basically a cavity inside of it, you have a specific type of fluid called perilymph. And the goal of this fluid is to protect another labyrinth inside of it called the membranous labyrinth. I know, it's complicated. Now, membranous labyrinth also has a fluid inside of it called endolymph. Now, give me a second. Let's just look at this and then we'll take a look at a picture. Now, when we're talking about the bony labyrinth, the internal ear, which is basically that bony labyrinth, is made up of 3 segments. And this should sound familiar to you. Your vestibuli, right? The 3 semicircular canals, and the shell of your snail called the cochlea. So let's take a look at this picture. So here is my middle ear. You have your 3 semicircular canals, 1, 2, 3, and they have their own names. You have this midsection called the vestibuli, and then the shell of your snail that is called the cochlea. So what you see right here as this kind of a yellowish color, that's your bony labyrinth, right? That's the protective shell. Inside of it is empty, right? So what is it filled with? It's filled with this lighter yellow color, which is called, which is a fluid called perilymph. Now, at the center of the perilymph, you have this blue color fluid called endolymph. And the space where the endolymph actually runs is called the membranous labyrinth. So protective shell is your bony labyrinth, which is filled with perilymph. And at the center of your perilymph, you have another opening or cavity called the membranous labyrinth. And within that, you have endolymph, right? The fluid endolymph. And again, it seems a little bit kind of wordy and complicated, but as we look at this structure on part 2 of the PowerPoint, hopefully this would make a little bit more sense.